Okay, 9EA. So on the first page we have lots about very futuristic materials. We have carbon nanotubes, which are really thin tubes. They're very light but very strong, and they are good thermal and electrical conductors. And it also talks about aerogels, which are also extremely lightweight but can carry really heavy loads. Those are your key points from page 1. Page 2 we get to ceramics. Now with ceramics, I want you to think about Superman. Superman is very tough. In very tricky situations, he stays cool, calm and collected, and he can protect people. He could stand in front of you and protect you from flames, from extreme heat, and from an electrical storm. The electrical storm wouldn't go through Superman to you, and that is exactly what I want you to think about when we think about ceramics. Ceramics are a type of material, and they have these properties. Ceramics are hard. They're heat resistant, they don't let heat and electricity pass through them very easily, so they're good insulators of heat and electricity. And they're very unreactive, just like Superman, not overreacting to really difficult situations. Something you have to remember here is the word brittle. Brittle to us means something quite weak and falls apart easily. But ceramics are hard and brittle, which seems like it doesn't make much sense. But something can be hard meaning that you can't compress it, can't squish it. But it can also be brittle, meaning that it can smash and it can crack. So it can be both of these things. Because ceramics, like Superman, have really good protection from heat, they're often used as the outside of spacecrafts. So on re-entry to Earth, that heat that's generated is not transferred through to the rest of the spacecraft remains protected. And because they're such a good insulator of electricity as well, they're used in pylons to support the electrical cables, so the electricity doesn't pass through the pylon itself, it just stays within those electrical cables. There are different types of ceramics. You have china, porcelain, pottery. The slight odd one out that they include in this category is glass, and there are reasons you'll see why it's included, but there are reasons like me where you might start to question why it's included in this category, but either way we still have to count glass as part of this category. And the reason why is because glass has these same physical properties, so it's hard, brittle, a good heat and electrical insulator, very unreactive. That's the reason it's included in the group. It's also included in the group because its atoms have strong bonds. The atoms in ceramics are very strongly bonded together. Let's talk more about these atoms. The atoms in ceramics sit in a lovely ordered pattern, structured, neat formation, connected together with these strong bonds. And this gives them this heat resistance and these high melting points. Again, a side note here on glass, although it has the strong bonds, it doesn't have that lovely neat structure. But it's still included in the category. And what does this look like when you zoom out a bit? Well, if you zoom out a bit, you see these crystal structures, because what's happened is the material used to make the ceramic, usually clay, in the case of glass, sand. When this original substance is heated up, chemical reactions occur, the ceramic is formed, and crystals start to form during the cooling down period. And fun fact that is in your book, so it's useful to know, the slower the cooling period, the larger the crystals, because they have more time to form beautifully into this lattice structure, into this rigid structure. So to recap, ceramics are in this group together because they have similar physical properties: hard, brittle, good insulator, unreactive, high melting point, heat resistant, just like Superman. Their atoms are structured and neat, and we call this a lattice structure. We've got this.